Hello, my name is Tanner Dunn. This is my project, my semester project. I am a student at CFCC. I am getting my associates in engineering. Currently, I'm taking the course EGR214 Numerical Methods for Engineers in the spring of 2022, taught by Dr. Hans Chapman. The related courses I will be using is Physics 2. My topic is current resistance. I will be solving for variables and functions relating to and corresponding to RC circuits. Some basic knowledge about RC circuits is that they, in the most general form, are a battery, a switch, a capacitor, and a resistor. Based off of some of the actual functions and different concepts we will be using, we can use this knowledge to further understand how they work and how time and disconnecting batteries or reconnecting them can change the charge on capacitors, or the current, or the max charge, and the difference between discharging and charging. A solved example from the text shows how we can apply some of our rules, such as tau, which is a time constant, which is resistance times capacitance. Our max charge is capacitance times our EMF, or our battery. Our initial current is EMF over resistance. And then our functions relate to these values being plugged in to them. Now for tutorial problem 1, an uncharged capacitor and a resistor are connected in series to a source of EMF. If our battery is 9 volts, our capacitor is 20 microfarads, and our resistor is 100 ohms, we need to find the time constant, the maximum charge, and the charge on the capacitor at a time equal to one time constant after the battery is connected. Now for tau, which is a Greek letter, and represents a time constant, which is much like radioactive decay or growth, you could say in this matter, or how long it would take to get to 67.3% charge on a capacitor. We can plug in our values of resistance times capacitance, which is ohms, which is the value ohms, and then the value of farads for the actual units. And this is farads, and then I typed in V here, but that is supposed to be EMF, and that is volts for batteries. So plugging that in, we get 0.002 seconds for our tau. For our max charge, we get 1.8 times 10 to the negative 4 coulombs, which is relating to our Qs. And then for our charge, when tau equals t, those would cancel out and equal 1 minus e to the negative 1, which equals 1.14 times 10 to the negative 4, and that's borrowing our max charge from previous. Our MATLAB numerical solution, we would be saying this as charge cap1.m. Our inputs would be resistance, capacitance, and electromotivity force, and our outputs would be charge, max charge, and tau. So actually going into what these values mean, resistance is measured in ohms, capacitance farads, and EMF is in volts. Our charge and our max charge are both measured in coulombs, whereas our time constant is actually measured in seconds. So we use the sims command because t doesn't have a variable, and then type in our tau, our max charge, and then our charge with respect to time. And then for this situation, because our time equals our time constant, just for this situation, it can change. We can then use these values and then plug in here. We specifically cannot plug in just charge cap. We have to have these values ahead of it just so we can get all three instead of just our charge. And then we plug in our 100 ohms, our 20 times 10 to the negative 6, or our 20 microfarads, and then our 9 volts. And then we get the same exact values, and this is an approximation, but is 1.14 times 10 to the negative 4. For tutorial problem 2, we are using a standard RC series circuit like described earlier, with the switch, the battery, the resistor, and the capacitor, not in that order, but anyways. Tau is some constant, and the max charge represented by capital Q. We will be finding the charge for an uncharged capacitor in a standard RC circuit based off of two instances of time. When time equals 0 and time is approaching infinity. Plugging in such values, since this is negative t over tau, that means we have 1 over e to the 0, which is just 1 over 1. So our charge would actually equal max charge times 0, which is 0. So as 0 time passes, no charge is gained. If t equals infinity, again, since this is a negative value, that's 1 over e to the infinity, which equals 1 over infinity, which is approximate to 0. Our max charge would equal, or our charge would equal max charge, which makes sense. An infinite amount of time would allow you to gain max charge. Now for our function, we will be saving this as charge cap2.m. Our inputs would be tau and a, which a is some variable where t is approaching a certain time, so either 0 or infinity. And we will be finding charge. You can supplement this for the symbol q, and then instead just type this function where q is, but I find this a lot better to read, and it still makes sense all the same. These values are the same, it just MATLAB, I don't want MATLAB to get confused. So in typing in all of our code, we have to make sure our tau is, since it's just a constant, it cannot be negative and it cannot be infinite. Eventually tau does reach some value where it's fully charged, the capacitor, because charge acts much like half-life, but instead it's how much time it takes to reach 67.3% of the full charge of a capacitor. And so the results we would get from this are the exact same, where if 0 time passes, we will have 0 charge, and if infinite time passes, we will get infinite charge. We are actually using, for our charge, a limit, so we can show that t is approaching infinite, because MATLAB does not like when you just put t equals to infinite. So just a heads up there for when you do try to use equations like this, make sure you have it as a limit, but it all works out the same still. So for my concluding statement, learning to solve different variables, functions, and expressions that correlate to RC circuits is a useful base of knowledge for all engineers to have. Not only can it strengthen your design solutions, but you can further communicate better with other engineers. Capacitors and resistors play a huge part of our lives in the 21st century. From all the technology that we use today, knowing how capacitors hold charge and how to use this technology can really strengthen us as engineers and how we work together. Through this manual, this base concept of RC circuits can be applied more efficiently through MATLAB. There are a lot of other concepts such as Kirchhoff's laws and loop equations, and how even different resistances and resistivity changes based on material, but those can all be built on later based off of what we've learned today. Thank you for your time.